You get to meet people. There's the secret track, which is just walking around, having a coffee, talking to people you don't know. Oh, what do you do? I do this. You learn so much and you extend your network amazingly well, and you cannot do this online. It has to be in person.
Hey everyone, I'm Sarthak. I'm going to be talking about C++23 deducing this. Quick intro, I'm a C++ low latency execution engineer at Maven Securities. We have offices in Chicago, London, and Amsterdam. So if you're ever curious about the space, feel free to reach out to me. And let's dive right into it. So say you start creating a class. In this example, I have a chessboard, which is an 8x8 chessboard. I'm storing it in an 8x8 array, and you want to give the clients access to the elements inside this chessboard. So you would typically start off by providing some accessor like this add function, which takes in the row and column and returns an L value reference to the chess piece. Well, this looks nice, but very soon you would realize that the object calling, or like the chessboard object might be a const object. So you would want to provide a const overload to this, which would hopefully return a const ref, and it will look something like this. You can also go a step further and have R value overloads and R value const overloads for this, and very soon it starts becoming very cumbersome, and you would realize that there's a lot of code duplication going on. Well, if you're on C++23, this is a conditional box of shame. You can get rid of all of this code and simply replace it by 3 lines at the bottom. And this is what deducing this does. It also does some other stuff, but I think it's really cool that we can now replace all of this boilerplate code just by using these 3 lines of code. And that's it. I could give you back 3.5 minutes, but I think I'm going to bore you with some more details of deducing this. So taking a step back, the chessboard looks something like this. I have a non-const overload of this add accessor, and I have a const overload of the same accessor. Now, pre-C++23, there's still code duplication, and as programmers, we don't really like to repeat code. So how would we deal with this pre-C++23? Pre-C++23. So what you could do is you could have a static member function, which is now at the top, I have this static add accessor, which is like a private method. And the first parameter that it takes is the auto reference to self. And if you notice the member functions, like the 2 member functions, the non-const overload and the const overload, they now pass the dereferenced this pointer, that is the object, to the static member function. So we've avoided code duplication now. And the nice thing about the solution is that the auto reference in the static member function is now going to be deduced as either an L value reference if you call if the object is non-const, or a const L value reference if the other add accessor is called. And you could do this pre-C++23, and I think this is a pretty cool solution. Deducing this basically addresses this, as I previously highlighted. I wanted to highlight a few things here. The first parameter in deducing, like in a member function which uses deducing this, is this like weird thing, this auto ref. This is a forwarding reference. One thing to notice that deducing this function is a non-static member function, not a static member function. And since it's using a forwarding reference, I'm using stood forward here. So I want to perfectly forward it and then access the data member. Now, consider this piece of code. I have a chessboard, and I'm trying to access a chess piece. And instead of simply calling chessboard.add, I'm moving the chessboard just for the sake of this example and calling the add member function. What I would expect this to happen is that it would resolve the type of chessboard is going to be like this type of explicit object parameter, auto ref self, is going to be an R value, a non-const R value to be clear, and that is what happens. That's expected. But now, would my chess piece be copy constructed or move constructed? Well, because I'm using a non-const R value reference, I would expect it to be move constructed. But in my current code, it's copy constructed. And C++, this happens because when I do stood forward on the self parameter, it is a null value, that's true. But as soon as I access the board, that now returns an L value reference to the board, and which ultimately returns an L value reference to the chess piece, and it copy constructs. So this is no good. C++23 introduces stood forward like, which basically instead of, you would access the board in the class and then wrap it with the same reference properties as the object itself. So I think stood forward like is pretty cool, and that's it. Thank you so much.